Then let's start. Thank you everyone for being here today. Joomla User Group Munich again online. And today our speaker is Ole Kröger. He's going to give an introduction on animations in Julia, visualizations. He built Javis as co-author. And yeah, he's working in Hamburg at a small startup, actually using Julia full-time. And what they do is they print shoes. So if you're interested, ask him also offline. I guess it's super interesting, small startup. And yeah, so we have a couple of audience. We still expect a couple of more people to join meanwhile. But let's start right away. So Ole Kröger, stage is yours.
Thanks, Stefan. So the talk today is about Javis.jl, which is an animation engine written in Julia. I think we created it about 3-4 years ago. Created it together with Jacob Zelko, who you might know as the Zeta Prince. He's also streaming on Twitch a couple of times. And now we, I think 2 or 3 years ago, we participated in Google Summer of Code. So 2 more students joined, and we get some contributions by others, mostly examples, sometimes some feature requests, bug reports, of course, and stuff like that. So today I will show you what is Javis. It's an animation engine. So what is an animation engine? I will show you some other animations engines which you might already heard about or at least seen in use. And there are 2 main points of Javis, which consists of objects. So things that you draw on the screen, like a circle, like a polygon, stuff like that. And then there are actions. So actions are used to rotate an object, translate from one position to the other, changing colors, changing size, all those things. And then quite early on in the presentation, I will show you lots and lots of examples, depending on how much time we have and how you want it to go. We can go into either showing you a Pluto notebook and show you Javis in action, or just have more time for questions and things like that. So what is Javis? Or as I said, what is an animation engine? And as one says, an image is worth 1,000 words. Why not use an animation? You can tell even more with that. An animation engine basically has the ability to create objects on the screen, so render them to a GIF, MP4, live stream them, whatever you wish, and of course to animate them. Those 3 things combine to the animation engine. Then there are 3 animations engines which you might have heard about. One is called Manim, which is written in Python and is extensively used by Grant Sanderson, which you might better know as the creator of 3 Blue, 1 Brown, and also the creator of Manim, which you might not know. It has also a community edition, which has more documentation, more readable code, and that kind of things. Then there are processing and P5.js. Processing is written in Java, and P5.js is basically the counterpart of processing, and obviously written in JavaScript. So to give you a rough idea of how the different concepts can be to create such an animation engine, I will show you an example here of Manim, then of processing of P5.js, and then we dive deeper into Javis. So here you can see first of all that Manim is using classes. So, and here you have a scene. You can construct the scene. It's easy to read that we create a circle, which has a specified radius, and it's filled by a red color. We add this circle to the screen, so we display it first, and then we have this play function to rotate a circle or rotate an object, in this case the circle, around a point, and then just like continuing with that animation. So pretty straightforward to read, I would say, and yeah, quite expressive. Then P5.js, it has only basic functions, so you can draw like a circle, but rotation is done by basically saying, okay, we want to rotate not just by this angle, but you actually compute the XY coordinates yourself. It is split up into a setup function and a draw function. So the setup function is basically everything that you need later on, your default values, I would say. And the draw function is something that is basically run in a for loop, or in a while loop, I should say. And you can see that you define like the size of the canvas. You define the center point as just like the center of the canvas. You create like a vector, which is just or a vector, which is then the point, just like a random position. You define an angle and the radius of the center. Then you, in the draw loop, you say the background color, you say the XY position of the circle, and then basically you rotate it around by having your own rotation function with cosine and sine. And at the very end, you draw the circle, so you specify like the color first, red, no strokes, so no border around the circle. Then you have the circle function, and then you define the angle. So basically the step size in which you want to rotate around. So this is like a huge contrast to what Manem does, but it gives you, it is very flexible. You manually create the frames, and it's just like longer to read, but you have all the flexibility that you want, which can also be nice for certain applications. And now to Jarvis, it has rich drawing functions due to the existence of Luxor. So Luxor was created, I read today in the discourse that it was created 9 years ago this month. And Jarvis uses it to basically draw anything on the canvas. So here, for example, this circle function is done by Luxor, and also setting the color is done by Luxor. And as said in the introduction, it's object and action based. So here you can see like we have a red ball, which is also called like an object. We call this function colored circle, and we specified a point where we want it. And this action, we have this act function, which acts on an object. And the action here is for every frame, we want to rotate around the origin. So this is an O, not a 0. And the O in Luxor stands for the origin, so the center point of the animation. And we want to have a full rotation, so of 2 pi. And yeah, this one basically, as I said, just like normal Luxor functionality, if you used that before. It's very flexible, I would say, and some animation functions are already given. So anim rotate around, translate, and things like that. And here we render it to a GIF in the end. And yeah, so we focused from the very beginning to So I will share a link to the Javis documentation later on. Here you can like basically read what this functionality does. We often have different options with multiple dispatch. So here we could have also assigned, okay, we want to start at angle 0, but normally it's angle 0, so we can drop it and things like that. And we also always show like an example, which you can basically just copy and paste and have an animation to start on and immediately see what it does, which I think is quite helpful. Then let's see like a comparison of the animation engines that I just mentioned. So Manim is written in Python. It allows for 2D and 3D animations. And you can create entire videos rather than short GIFs. You have like a huge community and a lot of content out there on YouTube, which I think is quite nice for Manim. Then processing in P5.js, written in Java and JavaScript, can also do 2D and 3D animations. I mostly saw 2D animations though, so just figured out today that it is also capable of 3D. It is very customizable, as I've shown, and you basically draw every frame yourself. It's just like a loop around it. You have some functionality for making drawing simpler. And then Javis is written in Julia. We only support 2D animations at the moment, as Luxor is only 2D. Currently, Comolian, the creator of Luxor, is working on drawing in 3D as well. So I think he started like 1 or 2 years ago. Don't know what the current process is there, but maybe at some point it can be also integrated in Javis. We have simple and predefined functionality, but it's still like quite flexible when needed. Yeah. And yeah, as Stefan wrote in the chat at the very beginning, feel free to ask questions at every slide whenever you want, basically. Feel free to interrupt me. Otherwise, I will just continue, and you can, of course, ask questions at the very end as well. So for the main parts of Javis, we have these options, actions, and frames. So objects are just the shapes that can be animated. So in this example, we have just a red circle. Actions are just like basically something that defines how an object shall behave. And frames, for all the stuff that I've just shown you, we always act like for the full length of the video or GIF on the object. So here we just rotate it all the time, but we could, of course, also just rotate half of the time and then just animate the translation for the rest, things like that. And that's where the frames come in.
One question,
So,
Stefan
yes.
speaking. You showed us the other packages out there, and it looked like Javis could have been motivated by Manus. Is this correct? Like having these object and action differences? Have you worked with the others and preferred the Manus way of doing it?
I worked before on doing some processing stuff. I haven't fully worked too much on using Manim because it was quite hard for me to like get started there. There was a lot of things to wrap my head around, and I was more focused on having like a very simple thing doing for like small GIFs instead of full videos. But for me, the processing stuff was a little bit too, like you have to do everything on your own. So we grabbed more there from Manim, where it's like easier to say, okay, we want to rotate around this object. We have some connections between objects, and things like that. So that's like the combination where Jarvis comes in, I would say. And the other thing is also created this to just like actually get my head around how to build an animation engine. Never expected that more people adopt it and things like that. So it was kind of a side project for me at the beginning. Yeah.
That's great.
Question?
Yeah, thanks. And I'm looking forward for this in between, having both the high level and the flexible parts. Yeah.
Perfect. Okay, so yeah, let's talk first about some objects. So I think this is the one that I've shown you before. You can define like the frames at this point here. So before we had like 1:70 for like 70 frames. But here I want to talk about like how this gets called, which is a little bit of how it works behind the scenes, but I think it's quite reasonable to understand this on how Jarvis works in that end. So basically, we take this function and call it for every frame that we are rendering that you specify, and we call it with the video object, which just contains information about basically the size of the frame, as well as like how many frames there are. Then we have the object itself, which doesn't give you too much information. Like there are a couple of things that we store there, like how many actions are attached to that object, things like that, and the frame number. But honestly, most of the time, you don't need that. So you can just say, okay, this is an anonymous function. It takes an endless amount of arguments, and then we draw the circle. Again, this is just like a Luxor function. So or like in this case, it's just like one Luxor command, but you can define your own function there, which then calls Luxor functions. Then as this arguments ... anonymous function is sometimes a little bit useless to write, and it's not like really necessary if you want to have basic things like a line, a box, and stuff like that, or a circle. We defined our own function objects like jline, jbox, jrect, jellipse, jstar, and jpoly. And basically what you can see here on the right is what would draw the things on the left for a single frame. And this J line starts at the origin and then goes to 0.100 minus 250. And you can, of course, specify the start point here as well. So you have several options there. Then we have a box, so the white box here, which is just defined by this point and this point. Similar for the rectangle, like you define this point and the width and the height of it. Sorry, this one. Then the ellipse, you can, of course, use it to draw like a circle as well by just having the same radius for both. Then the star, which is like a special function in Luxor to draw a star, so we integrated here as well. And then a general polygon, here this n-gon function with like 3 vertices is also coming from Luxor. And some of them, like you have this color argument, and you can always say whether you want to just like stroke the outline or whether you want to fill it. And those are basically the most simple objects that you can interact with. And now for the actions. So in this example here on the right hand side, which is kind of like a loading animation, we start with like the circles appear. So this is appear by scaling. So you can also appear by just fading in, changing the opacity. Then we have translate, so we move from the center outwards and then rotate around the origin, and in the whole animation we change the color of these little circles from like red to cyan and white in the end. So that's like the out fading animation is actually changing them to white. And this is all done by using animations.jl, which is a package where you define basically like some start points, some like basically values in which you can interpolate in between them. You define like a range of interpolation, which is always going from 0 to 1 in our case, and how you want to interpolate between them. So that there are different functions. One of them is linear, one is like jolin-io is more basically slowly starting, then ramping up and slowly finishing. And yeah, in our case, we have like a for loop for our, I think, 5 circles, and define the blob object first. Here we have like our standard circle functionality again. We define like the frame start, so they just appear one after the other. And regarding the frames, this is also like the 1 to 10 frame is basically starting at the beginning of that object. Object is 1. It's not like the global frame number 1. It's the beginning of the object. And then we have, you can either specify like a simple animation to interpolation functionality, here jolin-io from animations.jl, and then have your own function. So appear and the symbol scale basically means just that you're scaling it up to standard scale that you specify. So it's always like from 0 to 1. Or the other option is to have like an animation object. So in this case, this one, where you specify, okay, you want to start at the origin and then move to point 150 and 0. And you have like your jolin-io function here again. Similarly for this translate back animation, which you see like here at the very end, where it shines like to the left, but it's also changing the color to white at that point. And here it's noteworthy to mention that we always are looking from the point of reference of the object. So we are starting at the origin as well, just that the origin is here now instead of here for that object when we actually call that action. And for the color animation, it has now 3 values. So it goes like from the first frame is basically where it's red, then half the size of the animation length, it changes to cyan and then to white. And this works because this functionality or the color itself defines like standard operations plus minus multiplier, so on. And because we have 3 different values, we have like changing from here to here, changing from here to here, we have 2 different functions. And those are basically like your simple building blocks of Javis. So now let's go into some more examples of it. So probably you have heard of Game of Life, and if not, you can Google it later. You will also, I found out today, when you Google Game of Life, the Google homepage or the Google page search result page actually shows you some animations like this on the left and right side as well. So that's our first thing that we want to animate here. just like a short wrap up of what the game of life is, or what it consists of. It consists of basic cells, which are either dead or alive. Here the black cells are the alive cells and the white cells are the dead cells. And then you have these 4 simple rules. So you always look at like a 3x3 grid, and depending on how many neighbors are dead or alive, your own state changes. So either there are too many members around you, so you die of overpopulation, or there is reproduction, underpopulation, things like that. And then you start here with like a random configuration at the beginning and just see how it develops. And now to the code. As you will see later on as well, whenever there is functionality packages that you can already use, you use those instead of building it yourself, and just use Javis for like the animation part of it. Here you basically just define your constants, the color, the size of the frames, things like that. And then, not shown for simplicity here, is like you get the game of life steps, which results in like a 3-dimensional array. And later you can access, like for a special position at a special point in time, you get either a 1 when it's alive or 0 if it's dead. And then we have our matrix here, which is like a 10 by 10 grid. And we define each object for the full length again. We have rectangles with the box size. And then we have a color animation, so an animation object again. Here you see that, again, it goes from 0 to 1, but you define the number of steps, and then with this range function, you just get like 0, 0.1, 0.2, for example, for 11 steps. And here we use 20 steps. Then before, it was just like go from black to white, go from cyan to white, things like that. Here we just create an array again, where when it's 1, we say, okay, it's alive, 0, or otherwise we say it's dead, and use like some kind of functionality here as well. So if it would be linear, it would be just like graying out. We can like scale it up a little bit. You can see on animations.jl all the different curves that you can use, such that it's longer, basically white, and then jumps to black. You can have like a step curve where it just jumps immediately without any interpolation in between, things like that. And you could also use like the set hue functionality, which we used before, but here I used the change function. So the change function basically takes anything that it's evaluated here and applies it to a keyword argument that the object uses. So the JRect has like a color keyword argument, as you might remember from before. And here we want to change that by changing from black to white and so on. And then in the end, again, we render it to a GIF. Now, that were pretty basic animations so far. Now to something a little bit more complex, but not really more complex on the Java side, actually, more complex on like what your inputs are, but maybe give you some ideas of what Javas can do when you want to like create simple GIFs of physics animations. So there's this awesome package, differential equations.jl, which we use here and solve differential equations for basically this bouncing balls here. So we give like a start point and a velocity, and solve the equations with changing reflections on the borders. Here on the left-hand side, it's just like a standard rectangle. And on the right-hand side here, it is approximated by curves. So it starts at the basically the same, or not exactly the same position as on the left, as you can see, but after just a couple of bounces on the walls, it basically looks like chaos, and the walls never were even close to the same starting position, which I think is quite fascinating. And similarly for the middle graphic here, you have like a circle. So an outer circle, you have two balls jumping around in an elastic collision without any friction and other things that are too complicated to implement, and slightly different starting positions. So one is like just a tiny bit to the right, and then they fall down due to gravity, and after just a couple of bounces as well, you can see the chaos by just a tiny bit different starting position. Now this is of course just like a tiny fraction of the code, but I can show you the code later on if we still have time, and I can also share all the codes later, as well as the presentation with you if you want to check them out. So here we basically have timestamps coming from differential equations. So at which point in time does it have which position? This might be useful because differential equations can be used with adaptive timestamps, and such that you have like the position at frame 5 and frame 12, and then at frame 13, because there was a radical change because it was bouncing, things like that. And then you just have like the position again, which you then later change with the center keyword here, because we draw circles and the circle has a center as the keyword. And then we have like linear animation in between as well. And just one thing to point out, which might be a little bit counterintuitive sometimes when using Luxor and therefore also Javis, is that the y-axis on Luxor points down. And I think it's more common in certain applications to have the y-axis pointing up. And here, that's the reason why I just used the minus sign here for the y component. And then another funny thing that you can do in Javis and as well as in Luxor. So Luxor has some turtle animation functionality as well. And in Javis, we can use, like, it's easy to create our own turtle animations in Javis. One thing about turtle animations, for those of you who haven't heard about it, is you basically start with a turtle somewhere that's looking, let's say, up. The turtle has several functionalities, so you can rotate the circle by a little bit. You can move like in the direction the head is pointing of the turtle, and normally you can also say, okay, like move and have like a pen that draws where you're moving, or you have like a pen up functionality. So everything that comes out here is easily visualized by a pen plotter, for example, to draw like the Sierpinski triangle, or like an approximation of the Sierpinski triangle here as well. And as I said, we have like the functionality of like rotating the turtle head as well as moving in one direction. And here actually a couple of new things here is there is a JShape macro where you can define your own functionality with keyword arguments, such that you can use the change function that I showed you before. So here you could use change color, change or move length and direction I don't use anymore. I just see and things like that. And you can also return a position in the end. So this is like the JShape functionality, which is similar to like JRect and things like that, but you define your own things in there. And then this R frames is for relative frames. And here we want to set the start position of the turtle at the very beginning without like animating it. So I set it to just draw it at frame 0, basically without animation. And then we have the same thing for rotating, and I just want to animate the movement. So I think in this animation, like a movement of like 3 steps is like done in 2 frames, so you can't like really see it that much. But for smaller ones, you could easily animate the movement that way. And because it's like it knows how the rotation was before, you just have to rotate by like 60 degrees again. If you rotate by 60 degrees again, you've moved by 120. You don't have to calculate that logic by yourself. And then just like move always in X direction here, or you could always move up depending on how you want to like rotate your shape in between. And then we are close to the end of the presentation. So yeah, we still have 20 minutes time. There are different rendering outputs. So you can, like the standard one I've shown you is this GIF. This one of the turtle animation was an MP4. Those are like the normal things that you would use to either like create like a YouTube video or things like that. Or I use GIFs all the time for creating animations for my blog post. Then you have the optionality to use Jarvis in Jupyter Notebooks or in Pluto. And here on the right-hand side, we have like a very simple application of a live viewer. So you can enter your frame number and move back and forth. So this is kind of where this AKA debug helpers is coming from. Sometimes it's not really nice to wait a couple of minutes until an animation is done and then see that you did everything wrong and have to redo it. So with this, you can like start your code, immediately this window pops up, and then you can just scroll through. Sometimes you might be only interested in a couple of first frames, and then you say, okay, I can render everything to like an MP4 or GIF. And then there's also the functionality of streaming. So streaming, you can basically do a live stream on Twitch with OBS, and you can stream directly to it. I haven't used that for a long time, but we implemented it during like Google Summer of Code. Sometimes there are problems with the speed of the animations. So I think working a little bit more on the performance of Jarvis would help there as well. And then you can do it like as something as a background, which just do like streaming of some data information that you want to visualize for your Twitch stream or something like that. And yeah, I've shown you a couple of like new examples in this presentation that I just implemented for this presentation, basically. Here you can see a couple of more examples. Those three that you can see here are all from my blog, which you can check out. Then there are a couple of more examples on in the documentation. And like there were a lot of pull requests from other Julia developers who wanted to create animations with Javis, and then we asked them to publish their code. So we have like a list of not only tutorials, but just examples from users where you can see the animation and like have the code and just use it however you want. Then we have our Zulip channel, where you can see and discuss your animations, ask questions, things like that. Of course, if there are like bigger issues with Javis, bug reports and things like that, of course, just go to GitHub. And if you're interested, I've also done, I think about 2 years ago now, a full YouTube video, which I think is like 10 minutes long or something, completely in Javis, just as an experiment. Even though I think the most use in Javis is to create like small animations, GIFs for your blog. But if you want, you can also try it out to create like bigger projects, bigger YouTube videos with it as well. And now to some inspirations and thanks. There are like way too many people to thank for this, but here just like a couple of them who I want to mention for inspirations for the basically the animations that I did. One is Matt Henderson, who is doing all kinds of animations with a pen plotter, just like interesting physics or math animations. He also has a couple of videos on Numberphile, so the ones that I use with differential equations. It's basically what he did in, I think he used Mathematica for it. Then there's, of course, Grant Sanderson with a lot of animations on his YouTube channel. They're done in Manem. Then Daniel Schiffman is using processing and has a lot of tutorials for, I think he also did like the Collard's conjecture, which you can see in this one. He did some animations there, Hilbert curves and things like that. And then, of course, Komolian, who is the creator of Luxor, who I mentioned before. He also has a blog and has some animations there, which he does in Luxor, where he just like creates frame-by-frame animations there. Yeah, this concludes my presentation on Javis.jl. Please feel free to ask me questions. And yeah, hope you all enjoyed it and learned something.
Thank you very much, Ole. We have time for some more questions. I would have a first one. You spoke about, I forgot the name, the sea noise something for having kind of a smooth translation. I always had a hard time to understand what this transitioning is actually about. It's probably between frames now. Can you explain kind of a bit more, or if you have examples, even better, how would it look like to have another translation there?
Yes. How do I get out of this presentation mode? Okay. So I think the easy, you can see the animations.jl package now, right?
Yes.
Perfect. So you have different, yeah, they're called easing functions. So basically, you have different ways of how fast you interpolate in between. So this one is always like starting a little bit slower than ramping up. For the physics animations, I always like use linear, and you can have all kinds of different easing between like 2 frames, how it should be interpolated, if that answers your question.
Yeah, a little bit, maybe follow up. So the animations, we had these lists, which first defined parts, so 0 to 1, or like steps from 0 to 1. Then we had kind of the things which we want to interpolate, maybe the location or the color.
Yeah.
And then we had these easings. So that from our given, let's say, points in time, we construct kind of a smooth interpolation for every single time.
Exactly.
This is then what's happened. Okay, yeah, thanks. And yeah, and they probably have different effects, or so this is kind of the mathematical part of an easing, but they, as you say, the one is kind of, yeah, helpful for this or that. So linear is helpful for physics. Sine IO is helpful as a fallback, as a default. And yeah, and they have kind of different appearances, natural, yeah, like intuitive appearances.
Yes. So for example, for where's this? For this one, it's nice to have like the actual color for like a longer period of time, I would say. Otherwise, you see a lot of just smoosh out blobs, kind of. So you want to have more something like this 6 curve. So some of them also take like input values, so that you have black for a longer time, and then you have like a short period of actually changing from black to white. But if you would use like linear, it would just like always kind of be grayish, and you can't really see when it's black or when it's white. And if it would be like just step ease, so basically just like jumping from black to white, you know, like for that one, you probably can also use that. But I think some kind of animation in between there is quite nice as well.
Yeah, thank you. This helped visualizing the differences. There's some questions from our participants. You can also write in the chat if this simplifies it. I have a second one, a second question I'm really curious about. You mentioned the streaming. And I also was kind of, not surprised, but it was a bit obvious for me that all the examples had a fixed time frame or a fixed set of frames, like everything predefined. In streaming, it would be not that easily possible, or it doesn't make so much sense. It's more like an ongoing thing. Does the code then looks much different?
I haven't checked streaming for quite a while.
Yeah, you mentioned that.
And it was implemented by one of our students. But like normally you don't have to specify the frames like that often. Like you often specify frames for the very beginning of an animation, but yeah, you can probably check out our documentation to figure it out, to be honest.
Okay, I will take a look. This one for the question, yeah.
Yeah, good resources. So I have this open. So I think you can probably, the best way to start with Jarvis is go into our documentation and start with like tutorials 1 to 7, where you see that, for example, here one animation where you rotate around the different objects. I think it's the one that I showed, always rotated around like a point, but you also have access to the position of other objects, things like that. Then, as I said, there's this example list, which then you can just see the code with some comments for it as well. Those are the things that get you started with Jarvis, I would say. And of course, the other one is when you want to be interested in like inverse kinematics, for example, then on my blog, you see a description of how everything works with like more text instead of just reading the code, which might be simpler for you to get started than the example section. It's more like a tutorial with sometimes a little bit more advanced usage than the tutorials that we have in our official documentation, I would say. Does that answer your question, Thomas?
Thank you for the presentation. I have one question. Is there any plan to extend to 3D at a certain point in the future?
It's not currently planned. So there is this, I think it's called CBS package in Joule, which is also by Comolion. But yeah, he is like not working that often on it. So I think when this one has like more and more functionality of 3D objects, then there would be the possibility to also integrate it into Jarvis. Does that answer your question?
Okay, yes, thank you.
Perfect. The scalability of Jarvis. So that's a very good question. So I would say Jarvis is more for like creating animations with not like that many frames. So just showing something that is like, I don't know, maybe a minute long or something like that. And Manem is, I would say, like more powerful in that regard. It's used extensively for creating longer videos, things like that. For processing, with processing, you always have the, I don't know whether I mentioned that, but for processing, you basically, the computation time is your frame rate, because it just, you can, I think you can have like sleep functionality in between in the in your draw loop, so you can have like sleep 100 milliseconds or something. But if it takes longer to compute, then of course your frame rate drops. I'm pretty sure there are options to export it as GIFs and things like that. But there's also like the way I used it, and Daniel Schiffman from the coding train uses it a lot, is that you do it in your browser and then have like on the left hand side your code, and on the right hand side it's just like doing it in real time, basically rendering it, which is also quite nice for just simply like wrapping your head about some animation. But that's also more like for shorter animations. So processing or P5.js is also more like for generating smaller animations, I would say. Hope that answers your question, Danny. Yeah, I haven't done any benchmark testing on those yet, because it was not so far not the focus of us in Javis in general. But feel free to open like a pull request and put it in our documentation if you want.
Thanks a lot for a very interesting talk. Are any of these frameworks, would they be able to incorporate sound as well, so that you could sort of mix an animation of graphics and put some sounds on, maybe make some sort of multimedia stuff like that?
Not that I know of. Maybe Manim has that functionality, but I'm pretty sure processing doesn't, and Javis also doesn't have that functionality.
Would be fun.
Thank you all for the questions. I also see the spirit of having some background animations where music is synced to the visualization parts. This sounds like an awesome thing.
I think there are some audio packages in Julia as well, right? I think I talked to someone in one of the Julia conferences about it. So maybe there's an option to use that as well.
Yeah, should be possible. Like, yeah, just adapt the frame size, the frames per second to the audio file, and the rest you can compute just manually.
And I think also, of course, that would only be useful if you create like longer, like MP4 videos with it. So I would say, as mentioned before, the kind of like the main focus for me as I developed Javis was always because I wanted to put some animations in my blog posts. So that's the main route was always generating GIFs for me. But of course, there's like also the option to create MP4s and things like that. But it's not like the main focus that we put too much effort in, I would say. But that would definitely be nice to see some pull requests in the future and work on that more.
What is the most complex thing you have made in Javis?
Probably my YouTube video that I put a link in, so I can also share it. I don't know why that text is so huge. So there I used it to basically explain one of the longer blog post series that I'm doing is building a constraint solver. And there, like, I explain how it can be used to solve Sudokus and did these animations with Javis. But it's also like now, like 2 years ago. So I think we didn't have the J objects. We didn't have the change function for it and things like that, if I remember correctly. But that was definitely like the longest animation I have done, and most complex. I don't really know, to be honest. It depends always on like what is your pre-knowledge on things, I would say. So for this presentation, I worked with differential equations, .jl, which I haven't used before. So that was some kind of other complexity in there. And but on purely the Java side, can't really remember what the most complex one was.
Stefan here. Are there some other packages in the Julia ecosystem which try to solve similar problems?
I only know of Luxor, which has like, so, and I think you can also, I forgot the package name. What is the name of the Julia package which does 3D interactive? I'm not sure whether I could call it animations, but like draw things in 3D. I forgot the name of it. Are you still listening, Jacob? I saw that you entered before. I definitely know that you know what I'm talking about. But yeah, maybe it comes to me in a second. And I think Aki, yeah, thank you, John. So I'm not sure whether they can do animations as well, and then it would be 3D. So yeah, this is like the way that you can do it directly in Luxor, where you have like your frame number that you get. So that is pretty similar to processing, I would say. And then yeah, maybe Maki has maybe some animations as well. Oh yeah, yeah. But probably more, yeah, like basically or you can do animations using plots.jl, right? So that's like different kind of animations that you want to do, yeah.
Okay, then thanks again and have a good evening, everyone.
Thank you for listening. Hope you enjoyed it.